Good morning, everybody. Today we will learn milk proteins and their processing. I am A.K. Mukherjee, Assistant Professor in the Department of Food Technology, Haldia Institute of Technology. Let us see what is the composition of milk. Milk composition, percentage composition. Buffalo water is 82.14, protein 4.78, fat 5 to 7, lactose 4.81, and mineral or as 0.83%. Cow water is 87.27, protein 3.47, fat 3.7, lactose 3.66, and as 0.69%. Goat or sheep, these vary, but there is similarity in composition between the milks of these two animals. Water 84.14, protein 4.03, fat 3 to 6, higher percentage of fat, lactose 6%, mineral content significantly very high, 4 to 5%. What is milk plasma? Milk plasma is the fluid of milk without fat. So everything taken together and fat is removed from the milk is milk plasma. When dried, this fraction of milk produces skim milk powder. Milk serum, also called whey, is milk plasma without the casein micelles. When water is removed from milk plasma, it is called, the material which remains is called milk solid not fat, SNF. So these are the definitions of a few terms on milk. Milk casein, a colloidal aggregation of principal milk proteins. Casein is the main protein of milk. Casein micelles are formed within the aqueous phase of milk fluid. These casein molecules are charged, and this is due to phosphocasinate, phosphate and calcium. They remain together with the casein, forming a bridge, and the casein is polar due to this calcium, bivalent calcium, and they remain in colloidal suspension within the milk. Casein micelles are polar and remain in equilibrium with the ions and salts in aqueous phase. Their polarity and dimensions in the colloidal range are reasons for their stability in milk. See, there is a diagram given. The calcium phosphates, which are darker in color, these spots, and this is entire portion. This entire portion is casein micelle. So a large number of casein molecules, they cluster, they form a cluster due to their protruding their hydrophilic end towards the aqueous phase, while hydrophobic portion within this micelle formation take place. Here there are calcium ions and the phosphate also present with this casein. Here there is a picture, casein micelles in milk surrounded by fat globules. So fat globules are there, surrounded this yellow portion, fat globules. The fat of milk, these are having 2 to 30 micrometer size, and they are bound by a membrane which is made of phospholipid and protein, and they remain dispersed within the milk also along with the micelle of casein. The white portion here, these white portions are calcium, while these fibrous portion are beta casein and other casein molecules. Caseins are divided into 4 different classes, and these caseins forming a cluster. Casein of milk, casein micelle having dimension 10 to the power minus 4 to 10 to the power minus 5 millimeter, which is greater than the whey protein, and this casein and this micelle size is lower than the fat globules. These are intermediate in size between fat globules and lactose minerals in milk fluid. So first biggest is the fat, next come caseins, different caseins, and then the whey protein, and then lactose and minerals. Fat globules, casein, whey, lactose and minerals. Casein of milk is associated with calcium phosphate. Casein contributes to about 80% of the total proteins of milk. The remaining are about 18% lactoalbumin, 18 to 20% total, of which this lactoalbumin and globulin are there. However, lactoglobulin predominates in this percentage, in this fraction of whey. These are actually whey proteins. Milk caseins are of 4 types, namely alpha H1 casein, which is 23.6 kilodalton molecular size, molecular weight, alpha S2 casein, and alpha S2 casein and beta casein, which is 24 kilodalton, kappa casein 19 kilodalton. These 4. The another casein fraction, which is called gamma casein, which is actually the hydrolyzed product of beta casein, by enzyme, and it is not included here. Alpha H1 and beta caseins lack in secondary and tertiary structure. This point is very much important because they do not have secondary tertiary structure. The theoretical portions of these 4 casein fractions in bovine milk are approximately 38:10:36:12. So the alpha H1 fraction is the highest, and followed by beta, then this kappa and alpha S2. But it may vary by a few percentage in different samples of milk. That was the theoretical data. Here, analysis was done for a particular milk, protein composition of a bovine milk sample, and these percentages are found within that sample. Enzymes are there, those also contribute to the protein part of the milk. Alpha H1 is 26.9, alpha S2 7.3, beta 22.0, kappa casein 7.3, lactoalbumin 7.8, lactoalbumin, serum albumin, immunoglobulin. So these are the analytical value, practical analytical value. Isolation, how to isolate casein from milk. This is an age-old technique when we add acid, and also the milk contains some acidity which is due to lactic acid. When this acid percentage is such that the isoelectric pH of the casein is reached, then the casein portion, casein protein, is separated from the milk as precipitate. Milk has a pH of 6.5, while casein isoelectric point is 4.6. That is very age-old technique, and in small scale in home and in small preparation of this casein protein from milk, this technique is used. Precipitation with acid enzyme, first one. Precipitation by organic solvent, cryoprecipitation, that can also separate casein, membrane separation by ultrafiltration, high-speed centrifugation, ultracentrifugation. These are the common techniques for separation of caseins, where we get the casein as a mixture of all these different caseins, alpha S1, alpha S2, beta, kappa, gamma. So these are the techniques for separation. First one, precipitation with acid or enzyme. Casein is precipitated from milk at a pH of 4.6, the isoelectric point of this protein. Lowering of pH can be done with organic acids, usually under heated condition 50 to 60 degrees centigrade. Little heating is needed for separation of this protein. This is the age-old technique for small-scale production of milk casein. Co-precipitation with salt-acid combination. A salt like calcium chloride and acid can be added together at increased temperature, 90 degrees centigrade or so. Rennet enzyme also coagulates and separates casein. Enzymatic separation, which is this process is used in cheese preparation. Better yield of casein is reported by acidification of a portion of milk with strong ion exchangers. That means concentrated acids, hydrochloric sulfuric acid, to a pH of 2 at 10 degrees centigrade. This is then added to the remaining portion of the milk, which increases the pH to 4.6. So some portion is taken, acidified to a very low pH, highly acidic condition, and then this sample is transferred to the remaining part of the milk and the pH is increased to 4.6 while precipitation of casein takes place. By doing so, about 3.5% increase in yield is reported by this method. It was reported by Perry A and Darwin M. The resulting whey has a lower mineral content. So that means the whey need not be treated extensively and the protein can be collected by the usual procedure, which will be discussed later in this section. Increased casein yield is due to the retention of the card of the main protease peptone as consequence of hysteresis effect of solubility of this component. So when acid is added, the casein phosphate is separated from calcium and calcium precipitates as salt and whey is separated in liquid portion along with the proteins of whey. So this is the modified technique which also uses acid, but it is a little modified technique than the earlier, which is the conventional one. Precipitation by organic solvents. Hydrophobic solvents added in an aqueous solution of protein make the latter insoluble and precipitate it from the aqueous phase. This technique is utilized for many proteins which are soluble in aqueous phase. Obviously, these proteins are polar in nature and lose interaction with hydrating water when the organic solvent is added in sufficient volume. When organic solvent is added, the water is repelled from the vicinity of the polar casein molecules and they get ample opportunity to form a cluster and get separated out from the aqueous phase. About 40% ethanol can be used when the milk is in its natural pH, natural milk pH, but it has a relationship with pH. The amount of organic solvent required to precipitate entire portion of casein depends upon pH. When the milk pH is 6, requires only 10 to 15%. So lower the pH, lower is the amount of organic solvent needed for separation of casein by this method. Cryoprecipitation of casein. An aqueous solution or dispersion of solids, if frozen at a very low temperature like minus 10 degrees centigrade, the water along with the solid crystallizes, destabilizing the hydrated network. The lactose is also present within the milk, and that also tend to crystallize. The most insoluble lactose portion is alpha lactose within the milk. Once it is crystallized and rehydrated, the alpha lactose undergo mutarotation to form alpha and beta. Alpha and beta, these two form alpha and beta lactose. They undergo mutarotation. Now, while an equilibrium is reached, about 37% of alpha and 63% of beta is available. So, on progress of time, when thawing is done, after the milk is frozen and taken out of the refrigerator, then slowly and slowly lactose concentration increases in solution, which is accompanied by the separation of this protein casein, because casein do not have opportunity to collect water molecule and get hydrated before the lactose. That is one concept. Another thing is that once the sample is thawed, ice slowly melts, making the environment for the solids different, where the latter are precipitated. The calcium ion is separated and forms calcium phosphate. The monocalcium phosphate, it is converted through a series of changes. Monocalcium phosphate, CaHPO4, Ca, monohydrogen phosphate, CaH2PO4 whole twice, and then finally Ca3PO4. Finally Ca3PO4. Now, since calcium becomes unavailable, the bridge is not formed by the casein molecules, and they cannot remain in solution for a long time and are separated. So one concept is due to lactose, and another is due to separation of calcium and immediate dissolution of calcium during thawing before the casein goes into the water, comes in contact with water molecules and get hydrated. So cryoprecipitation depends upon freezing first and then the thawing operation, during which calcium is separated. It is also assumed that the lactose of milk is dissolved in dissolved form prevents precipitation of casein. Lactose is hygroscopic, particularly the beta portion. Freezing leads to crystallization of lactose, and at higher concentration this sugar retains many unfrozen molecules of water along with ions collected from milk casein. Once crystallization of the lactose had occurred in the samples of frozen concentrated milk, the casein precipitated. So that is the cryoprecipitation. Also, this lactose form a glass. When milk is dried, lactose is not immediately crystallized and water is not removed. Rather, it forms a viscous solution, and which is called glass. Lactose glass is formed during drying of milk. Membrane separation, ultrafiltration. It is not ordinary membrane we require ultrafiltration membrane which has porosity of 0.001 to zero point 0.1 millimeter, which is smaller than the microfiltration membranes. Microfiltration membranes having porosity greater than 0.1 millimeter, and a range of porosities for different membranes and different applications are available. The molecular cutoff for ultrafiltration is around 10 to 75 kilodalton. Pressure is required for this type of filtration, and a pressure of 1 to 10 bar in case of this ultrafiltration is needed. The lower the porosity, greater is the pressure required to continue with the filtration process. Large-scale whey protein concentrates can be effectively prepared from whole milk by this method. So once we do a filtration of the whole milk using membrane, the permeate portion is the whey portion, while the retentate portion is casein. Flux for a membrane filtration is given as transmembrane pressure divided by viscosity of solvent into residence time. Efficiency is percentage recovery, product of percentage recovery, and percentage availability of filter. That means how much time as compared to the total time we can use that filter. Total time also include the separation, the removal of cake from the filter, because due to very high pressure there is membrane fouling which takes place, and that time filtration cannot take place. So total time, the time during which filtration taking place divided by the total time is the availability of the filter. High speed centrifugation, ultracentrifugation. This centrifugation is done at a very high centrifugal force, 10 to the power 5 times of gravity force, and longer time is needed, above 1 hour, 2 to 3 hours are most common, of operation can separate casein from whey of milk. Almost all caseins of milk can be separated by this technique. From the point of view of nutrition, milk casein separation or any other protein like whey protein separation is not only a method to separate the component, but to retain the functionality of that particular protein. Membrane filtration is important and useful because the functionality of the protein is restored. The thermal treatment and coagulation of protein followed by its separation by centrifugation or filtration destroys the functional property of the protein, and that is that raises the question of those techniques. A technique is described for the separation by ultracentrifugation of up to 99% casein from milk. That means a very pure form of casein can be obtained. The casein gel is transformed by an ion exchange procedure to colloidal alkali caseinate and finally submitted to electrophoretic analysis. This technique guarantees that there is no loss in casein fraction. So almost all casein of the milk can be separated by this technique as stated by these authors. The reference is given. Now comes how to separate once casein is separated from the whole milk. Now we are trying to separate the different casein fractions from that total casein protein of milk. Alpha S1 casein, alpha S2 casein, beta casein and kappa casein. The beta casein actually having very high dispersibility and it is also emulsifier in nature. The beta casein is actually different. Its physical properties are different from alpha caseins, and kappa casein actually gives stability to the micelle. Kappa casein is responsible for stability to the micelle. So processes fractionation processes using urea solution at acidic pH. We can separate fractional precipitation can be done. Selective precipitation with calcium chloride, ion exchange chromatography with DEAE, diethyl aminoethyl cellulose, etc. Native casein. When milk is subjected to this separation of casein protein and we get the casein protein with all its functionality retained, we call this casein as native casein, but it is scarcely found in all its functionality retained in that form. So preparation by electrodialysis at 10 degrees centigrade of skim milk. One skim milk means water is removed by drying prior to this operation. Centrifugation and washing of the casein sediment with water. So again, this washing of this casein, first of all addition of water and electrodialysis while after acidifying to pH 5, followed by centrifugation of that precipitate and then washing, resedimentation of casein concentration by ultrafiltration, followed by again drying to get the casein powder. Dried casein prepared by this method is readily soluble in water. It almost resembles native casein micelles of raw milk. However, it is soluble in water. Now we are going to whey proteins. Whey proteins are smaller in size than the casein micelles, but bigger than the lactose and minerals of milk. The permeate stream of casein filtration includes whey proteins in aqueous phase with other smaller non-protein components of milk. Whey proteins contribute to about 20% or less of the total protein of milk. So once we do a ultrafiltration, the permeate section collecting lot of water along with whey protein and those minerals, because minerals are lowest in size among all these constituents of milk, and they also pass through the membrane pore and they are collected with this whey portion. The common process is acid rainade or heat applied for isolation of whey proteins. We can coagulate the whey protein and then we can separate by centrifugation. That means thermal treatment can be done at a very high temperature and their denaturation takes place. That is why they are separated out of the aqueous phase. But this technique actually destroys the functionality. Whey proteins are not usually found in its all functional forms retained within the sample, because these common techniques, and so far actually we neglect this whey portion of milk. We actually give importance to the casein protein of the milk. The main proteins in whey are beta lactoglobulin and alpha lactoalbumin. They are highly nutritious. They contain lysine, amino acid, essential amino acid, tryptophan and lysine. Beta lactoglobulin constitutes about 50% of whey proteins. So here some data are given. Cow's milk, goat's milk, sheep's milk. The lactoalbumin 1.16 in case of cow's milk, lactoglobulin 1.19 B and A and A lactoglobulin 2.87, making a total of 4.1. In case of goat milk, it is lactoalbumin, lactoglobulin, and in case of sheep's milk, lactoalbumin and lactoglobulin. So globulin is 5.97. So these data are collected from these authors. They have described in this journal. So lactoglobulin, its percentage is higher in milk. Isolation, whey protein isolation. The aqueous portion of whey contains about 4 to 6 gram of true proteins per liter. So it is 0.4 to 0.6% of solid protein available within that whey portion. The main proteins in whey are beta lactoglobulin with molecular weight 18.3 kilodalton and alpha lactalbumin and alpha lactalbumin 14.2 kilodalton. Beta lactoglobulin constitutes 50% of whey proteins. However, lactoglobulins can cause development of allergy to cow's milk, mainly affecting children. There are some research which found that there is allergy which is developed within the infants. So, to some extent, this functionality is not desired on this account. Nutritionally rich whey proteins have excellent functional properties with abundance of lysine and tryptophan amino acid. One such technique which is described in literature, whey protein concentrate can be produced, which is 35 to 85% protein, can be prepared by membrane filtration technique. WPCs prepared by this technique have excellent solubility in water at varying pH, high water retention capacity, and foaming and gelling property. So the same technique which is described in a flow chart. Industrial scale WPC preparation. Whey is subjected to cooling to 2 degrees centigrade at pH 7.3, followed by adjustment of calcium by addition from outside to 1.2 gram per kg, and then heating to 50 degrees centigrade for 8 minutes. This process precipitates lipid portion of whey. Microfiltration, ultrafiltration, diafiltration. Diafiltration is almost the same to that of ultrafiltration. Microfiltration having bigger pore size, that means the permeate which is separated, the molecules are having bigger size as compared to those obtained in the permeate of ultrafiltration. So first microfiltration is done, followed by ultrafiltration, then this diafiltration. So we get the lipid separated as residue, and in concentrate, whey protein concentrate, 95% pure whey protein concentrate is available. Here there is a diagram, pre-treated whey. So successive ultrafiltration membrane is used. High pressure can be generated with the fluid itself or by nitrogen gas. There can be arrangement for stirring etc. within this chamber, and this permeate and WPC are separated, followed by another ultrafiltration where another permeate and WPC 60. Finally, it is actually whey protein isolate above 90% can be generated by using a number of ultrafiltration and microfiltration units. Gel filtration, second technique is gel filtration. This is an alternative to ultrafiltration, but not so economically competitive in the industrial scale. Number two is not adopted by the industries yet. Number three, precipitation of whey proteins with polyionic compounds like polyphosphates and resolubilization of proteins for the separation of the former. First of all, the proteins are separated as precipitates, and then this protein is dissolved while the ions are separated from the protein. The fractions of whey protein fractionation can also be done. Fractionation of whey proteins can also be done by salting out, ion exchange chromatography, crystallization, and by membrane filtration. Thank you.